Yeah. Guys, this is the organization who is managing IP addressing. Later you will learn about the ES number, autonomous system number. And actually they are distributing the IP addresses to RIR, registry, regional internet registry. Right, like in your company there will be one RIR, you can check. So if you need like let's say block of IP, public IP addresses, you will request to RIR, registry internet, sorry, regional internet registry, and they will provide you the block of IP address. Same thing will happen for the ES number also. Later you will learn the autonomous system number. So there are again two types of autonomous system number, private, public. INA is the main organization, right? INA. May I know the length of IPv4 address? What is the length of IPv4 address?
32 bits.
32 bit. Yesterday we had discussed this. And how many fields are there?
4 blocks are there.
4 fields are there. Each field will carry how many bits?
8 bits.
8 bits.
8 bits. And with the help of 8 bits, what minimum value and maximum value you can write in decimal?
002 to 55.
0 to 255.
5.
So the lowest IPv4 address can be
0.0.1. Yeah, 0 network.
Means all bits are, all 32 bits are 0.
0.
And the largest IPv4 address can be
255.
255.255.
Means all bits are 1 in all
1.
the fields. Right?
Yes, sir.
Then how we divide IPv4 address into classes on the basis of what value? On the basis of value percent in?
Class A 0 to 127.
No. That is the range of class A. On the basis of?
Host and network that we can make in it.
Yeah. On the basis
most
of
significant
value
bit.
percent in first octet. Like if value in first octet is from 0 to 127, that means that IP address belongs to class E. So we divide IPv4 address into classes on the basis of value present in first octet. Guys, for the subnetting, you know, you should have knowledge about binary to decimal. Binary to decimal of 8 bits. Like if all 8 bits are 0, 8, then what will be the decimal value? If 7 bits are 0 and 1 bit, last bit is 1, then what will be the decimal value? Like all for
Sir,
all
you are not sharing the screen, sir.
Okay. Sorry. Right. For all the possibility, like how many possibility are there? 255. So you should have knowledge about binary to decimal and decimal to binary. Like how to convert this binary into decimal, this binary into decimal, this binary into decimal, right? So decimal value of this binary is going to be what? 1. Decimal value of this binary is going to be what? 2.
2.
Decimal value of this binary is going to be
127.
128.
128, sorry.
Right? Binary of this value is going to be what? Sorry, decimal
192.
of this binary?
192.
Very good. 192.
2.
Binary of 1110.
192 plus 32 is
24.
equal to 224.
224. Right. If 4 bits are 1 and 4 bits are 0, then
240.
240.
if 5 bits are 1 and 3 bits are 0,
248.
then
248.
248. If 6 bits are 1 and 2 bits are 0,
252.
252.
2. If 7 bits are 1 and 1 bit is 0,
254.
254. And if all bits are 1, then value decimal value is going to be 255. So you should have knowledge about this binary to decimal, how we are converting it. And guys, for the classes, you know how we got the range. To got the range, we have actually reserved 1 bit for class A, 2 bit for class B, 3 bit for class C. In first field, to understand the classes, IPv4 classes, you need to understand only first octet. Only first octet. So let's say this is first octet, or you can say first field. In the first field, value can be 0 to 255, means value can be, all bits can be 0, 2, 4, 6, 7, 8, or all bits can be 1, right? This will give me the minimum value, this will give me the maximum value, right? So for class A, what we did, to get the range only, for class A, to get the range, what we did, we reserve 1 bit. That first bit is going to be always 0. I have reserved 1 bit, that this bit will be always 0. So how many free bits are there in first octet now? 7. Out of 8 bits I have reserved 1 bit, right? So 7 bits are there. So if those all 7 bits is going to be 0, then I will get the minimum value for class A, right? And if all 7 bits are 1, then I will get maximum value for class A, right? So now you can convert it into decimal. Decimal of these all binary will be 0. Decimal of these all binary will be what? 127. Getting my point? So that's why I'm saying you should have knowledge about the binary to decimal for 8 bits at least, right? So here we will get value 0, here we will get value 127, right? Actually this is what 2 to the power 0 means 1. This second one is 2 to the power 1 means 2. This one is 2 to the power 3 means 2 to the power 2, sorry, 4. This fourth one is 2 to the power 4.
3.
4.
8.
Yeah. And so on. So if I will talk about these 8 bits, right? So first value is representing what? 2 to the power 0. This one is 2 to the power 0, 2 power 1, 2 power 2, and so on. This one is then 2 to the power 7, and 2 to the power 7 is what? 128, right? This one is 2 to the power 6 means 64. This one is 2 to the power
32.
5 means 32. 2 to the power 4 means 16, right? 8, 4, 2, 1. So if you will add these all value, you will get 255 only, correct? So this bit is, if first bit is 0 in the first octet, then I will get this range. For class B, guys, in the same way, for class B we have reserved 2 bit. How I have reserved 2 bit for class B? I have reserved that first bit is going to be always 1 and second bit is always going to be 0. 2 bits are reserved for class B. So how many bits are free? 6 bits are free, because out of 8 bits I have reserved 2 bit, right? So if all 6 bits are 0, then I will get minimum value, and if all these 6 bits are 1, then I will get maximum value. Again, when you will convert it into decimal, here you will get value what? 128, because see, all are 0 except first bit. First bit is 2 to the power 7 means 128. So here we will get what value? 128. And here again, if you will convert this into binary, So this one is 2 to the power 7 means 128 plus 0 plus 2 to the power 5 32 plus 16 plus 8 plus 4 plus 2 plus 1. So what value you will get here? 191. So like this I got range for class B. In the same way for class C I have reserved how many bit? 3 bit. First bit will be always 1, second bit will be also 1, and third bit will be 0. First 1, second bit 1, third bit 0. This is the reserve. These are the reserve bits for class A, class B, class C. For all classes I have reserved some bits to get range for each classes. Class C. Right. So how many free bits are there? 5. So 5 bit can be 0, then you will get the minimum value for class C. If 5 bits are 1, then you will get maximum value for class C. So from class A, how many network I can design? How many network bits are there? For class A by default, subnet mask is guys 255.255.255 dot. For class A 255.0.0.0 for class A 255.0.0.0 means 8 network bits are there. That means I can design 2 to the power 8 network, but I have already reserved 1 bits. That means 7 bits are free. So I can design 2 to the power 7 network from class A. From class B, how many network I can design? For class B, how many network bits are there? 255.255.0.0. 16 network bits are there. And out of 16 network bits, I have reserved 2 bit. Means how many free bits are there? 14. So I can design 2 to the power 14 network. In the same way from class C, 255.255.255.0. So we have 24 network bits and I have reserved 3 bits. So I can design 2 to the power 21 network. This is the default subnet mask for each class. And whenever you are using the default subnet mask with the IP address, that is called guys classful IP address. That is called classful IP address. Classless IP address means subnetted, right? Now some formula. First formula is how to calculate number of networks. So guys, formula to calculate number of network is 2 power n, where n is network bits, where n is network bits. So from all class you can calculate the number of network. Formula is very simple, right? 2 power n, where n is the network bits. So I am able to see in class A we have 8 network bits, and we also know we have already reserved 1 bit. That means in class A we have 7 free network bits, means we can design 2 to the power 7 network. Then how to find the valid IP addresses or number of IP address? So guys, formula to calculate number of IP address is 2 power h, where h is host bits. H is host bits. These are the 2 formula to calculate number of IP address and number of network. Then there is one more formula, that is block size, right? We will discuss block size soon, but let me write the formula here for now. block size. Formula to calculate block size is 256 minus subnet mask of last field. That's it. We have only these three formulas for entire subnetting, entire IPv4 subnetting. So if I am writing one subnet mask here, and that subnet mask is 255 dot, let's say 128.0.0, can you tell me how many network I can design here? How many networks are there? Yes, tell me guys.
2 to the power network bits. So network bits are 8 and 9.
9. Right? How many IP addresses are there?
32 minus 9.
2 power?
23.
2 power? What is the value of H? H is host bit. How many host bits are there? How many network bits? You are able to see in this IP address
23.
9 bits are network bits. Network. That means out of 32 bits IP address, if 9 bits are network bits, means how many host bits are there?
23.
23. So I can say n equals 9, so h equals 23. So total number of IP address is 2 power 23. Right? So hope you can find the network number of network and the valid IP address in any subnet mask. Subnet mask is a tool which specify how many network bits are there and how many host bits are there. All ones are network bits, all zeros are host bits. That's it. So if subnet mask is, let's say, 255.255.255.0, so how many networks are there, guys?
24.
24.
2 power 24 network, because there are 24 ones network bits. And how many valid IP addresses are there?
8.
2 power
2 to the power 8.
2 power 8. So you can see, when we have more number of host bit, then we have more number of IP address. Or you can say, when we have less number of network bits, then we have more number of IP address. So from where I am getting IP address? I am getting IP address from the host portion only. I am getting IP address from the host bits only. So if host bits are more, that means IP addresses are, number of IP addresses are more. If network bits are more, that means total number of networks are more. And valid hosts are less. If we will increase the network bits, what will happen? Increasing the network bits means
Reducing host bit.
network bits means decreasing the host bits.
Yes.
Decreasing the host bit. It means number of networks will be increasing and IP addresses will be decreasing. Is it clear? So now tell me one thing. How many IP addresses are there in class A? Class A. How many IP addresses are there?
2 to the power of 24.
2 power 24. How many IP addresses are there in class B?
2 to the power of 16.
2 power 16. And how many IP addresses are there in class C?
2 power 8.
2 power
8.
right? So guys, if my company size is less, like a small, then I will be using IP address from which class? From class C. In class C, how many IP addresses are there? 2 power 8 means around 256. 256 IP addresses are there in class C. So if I need, let's say I am designing a network for a company where 200 clients are there or 100 clients are there, definitely I will use IP from class C, because if I will use IP from class B, then I will be wasting lots of IP addresses. But guys, by default we are getting minimum to minimum 256 IP address. We don't have any size of network where we have less than 256 IP address. Like I need to design a network for 10 computers only, so I need only 10 IP addresses. I will use IP address from class C and I will be wasting 240 IP addresses, around 240 IP addresses. So to reduce this wasting, we come up with subnetting. To reduce this wastage, we come up with subnetting. With the help of subnetting, we can divide these network. These are the by default classful network. By default classful network. Classful network. Class A. Range is 0 to 127. Subnet mask is 255.0.0.0. Number of networks are 2 power 8, right? But again, if you will consider the first bit, which is reserved for the range, then you will have only 7. So if this is a question in, let's say, CCNA exam, then guys you will select 2 to power 7 only. This is the exam question of CCNA 200301. Question was, how many network I can design from class A, and the options are, first option 2 power 8, option B 2 power 7, option C 2 power 16, option D 2 to the power 21. So which option is right? Most of the people are saying 2 to the power 8, but this is again incorrect answer. Correct answer is 2 power 7. Got it? And guys, number of valid host, valid or IP addresses are 2 power 8, sorry, 24. So we have lots of IP addresses in class A. In the same way for class B, this is class full. For class B, range is 128 to 191. 1, and subnet mask is 255.255.0.0. Total number of networks are 2 to the power 16, and valid host is 2 power 16. For class C, As a network engineer, you are going to work on these classes only: class A, class B, class C. 192.2.2.2.3 and subnet mask. Number of network. Yeah, this one is the default, or you can say classful network. Clear? Any question till here? Anybody? Clear? Now we are going to understand the subnetting. Guys, the issue here is, see, by default the minimum IP address which I will get is 256 in class C, right? Either I can have 256 IP addresses, or I can have 2 power 16 IP addresses, or I can have 2 power 24 IP addresses. Only these three options are there. To get more options, we come up with subnetting. In subnetting, we will play with subnet mask. We can increase the number of network bits according to our requirement. If I will increase the network bits, what will happen? Number of network will increase and IP addresses will decrease, right? So question, subnetting. Why subnetting? Why subnetting? Subnetting or you can say we come up with subnetting to reduce the wastage of IPv4 address. Whenever we will discuss any topic, first we will discuss what? Why. Then we will discuss what it is, and after that we'll see how, and then we'll do the lab of that topic. Why, what, how, lab, right? So why subnetting? To reduce the wastage. Just assume I am going to design one network for my company. My manager told me to be ready with one blueprint for a new sites where they are going to connect 10 number of computers. 10 computers are there, 10 PCs, right? So they have also, asked me for the devices requirement, like how many devices are required, networking devices. So I said you need 10 number of PCs. First of all, client devices. It can be not only PC, it can be mobile device, it can be IoT device, it can be PC, it can be printer, server, IP phone, anything. Then I said you need one switch, that is a centralized device to connect these all computers together. Then you need one router. If you need security, then you can purchase one firewall also. Now this is the design, physical design. This is what, guys? Physical design. I can connect my router to internet, but can this user communicate? No. This user cannot communicate until and unless we will not configure the IP addresses. So two things are required, physical and logical. Logically also this network should be connected. Physically these all devices are connected, but logically these devices are not connected. How logically you will connect these devices? You have to configure address, right? How we are identifying the devices in network with the help of address. Two types of addresses are there, MAC address and IP address. MAC address is the address which will assign to devices by manufacturing company. Who is going to assign MAC addresses? Manufacturing company, right? Let's say this is a laptop of IBM. So this is a responsibility of IBM to assign MAC address. But who will assign the IP address? Network engineer. You are going to configure the IP address. So the first thing is which subnet we will use here. Which subnet we will use over here. So guys, I need what? 10 number of IP addresses. If I will use subnet from class C, then I will get 256 IP address. Network size is large. Now, if you are thinking that, Praphul, what happened? What is the issue to use IP from class C? This is a private, right? Free. No worry, we are wasting lots of IP addresses. So what happened? We will use a subnet from the class C. We'll use 10 IP address and we'll waste that IP address, waste all IP addresses. What is the issue there? Bro, there is issue. There is no security for the performance. For the performance, see, if this router is going to maintain a subnet in the routing table like 192.168.10.0/24 or subnet mask 255.255.255.0. Another subnet is 10.1.1. or 10.0.0.0/8. Do you think router is going to use same resources, same memory, same everything for both subnet? Then you are wrong. Router is going to focus more on this entry, because in this entry how many valid IP addresses are there? There are lots of IP address. That means this subnet is representing lots of hosts and this subnet is representing only 256 hosts. So router, with the help of this subnet network, router is managing 256 IP addresses. With the help of this subnet, router is managing lots of IP addresses. So network size should be smaller for the better performance. There will be difference in case of this subnet and this subnet in CPU utilization. So here is the issue. If I need only 10 IP addresses, I cannot use subnet from class C. That's why we come up with what? Subnetting. With the help of subnetting, guys, we can divide this large network into a smaller part. We can divide this network into a smaller part. Subnetting is nothing but the process of dividing large network into a smaller network. If someone is asking you, he explains subnetting, or let's say you are in front of interviewer asks you this question, tell me what is subnetting. So just say subnetting is a process of dividing large network into a smaller network. By default from class C I am getting 256 IP addresses, but with the help of subnetting I can divide it into two parts. Guys, if I will divide it into two parts, then how many IP addresses I will get in one network? 256 divided by 2. Correct? 1 to 8. If I will divide class C subnet into 4 parts, I will get only 64 IP addresses. If I will divide it into 8 parts, I will get only 32 IP addresses. If I will divide it into 16 parts, I will get only 16 IP addresses. This is perfect for my requirement. So I need to divide this network, class C network, into 16 parts. Question.
So I have a question over
Yeah,
here.
go ahead.
Hello.
Yeah, go ahead, bro. Am I audible?
Yeah. So why do you need divide these network? Like since one IP is belonging to the one organization, so why do you need divide into
So I
two
told you,
parts or
na,
four parts?
we are dividing it for the better performance. For the better performance.
But
Bro, just imagine you are, or just imagine there is one guard managing 1000 people by this guard and managing 10 number of people by guard. Is there difference in both? Answer is yes, definitely yes. Same thing is happening with routers. On the router, if I am adding a network 10.0.0.0/8, this time router is managing 2 to the power 24 IP addresses. If I am writing 10.0.0.0/24, this time this router is managing only 256 IP addresses, means 2 to the power 8 IP addresses. So again there is difference in both, like this guard. For guard, it will be easier to manage 10 people as compared to 1000 people. I am not saying this guard cannot manage 1000 people, but performance will be better here while managing 10 people. In the same way, on the router, performance will be better while using this subnet instead of this subnet. If you need this one, if you need 2 to the power 24 IP address, no problem, you should use. But if you don't need, if you need only 256 IP address, then don't use this /8. There is security as well. How security, guys? Just assume this is router, this is switch, and here I have PCs. Here I have PCs. I have 10 number of PCs. Right? I am using subnet from class C 192.168.10.0/24. Right? First IP address of first PC is 10.1. Last IP is 10.10. Now rest are free. So anyone, any attacker can configure .10 IP address, and if they will connect their computer to your network, now they can attack. How this attacker have attacked in your network? With the help of free IP address. But just assume if there was no any IP address available in the subnet, then no one can connect in your network. If you need more IP address, you can again change the subnet. You can change the subnet. This is not like if IPv4 like private IP addresses are free, then we can use any subnet. No, no, no. Because of performance, because of security. If your network size is small, then performance is high. You can see if number of valid IP addresses are increasing, that means CPU utilization is increasing. And you know, guys, whenever CPU utilization will be increasing, then performance will be decreasing. Yes or no? Right? So it is clear that subnetting is used to divide large network into a smaller network. Then why we need to divide large network into a smaller network? Because of better performance, better security, to avoid the, you can say, wastage. Like, so in section of why subnetting, we can say, let me change the topic name, say why subnetting. Here I can say improved security, better performance. Is it visible now? It will be easier for troubleshooting. You tell me, like you have two scenarios and there is problem, you are troubleshooting. One is 10.0.0.0/8. This is the subnet. Another subnet is 192.168.1. 1.0/24. Which will be easier for you to troubleshoot? Definitely this one, right? Because the number of IP addresses are less in this network as compared to this, right? While troubleshooting, when you will see /8, oh my god, it is going to divert your mind. That means lots of IP addresses are there, lots of devices are there, network size is very large. If network size is large, then troubleshooting is complicated. If network size is small, if you will divide this network into multiple part, into 4 part, then troubleshooting is going to be easy, right? Because guys, see, if there is some issue in this network, then I have to check everything in the entire network. But after the division, if there is some issue, first of all we can identify the issue is in which part, right? In which network. If there is issue in this section, I need to troubleshoot only this section. I don't need to troubleshoot the entire domain, right? So a small network is going to give you simplified troubleshooting. These are the reason why subnetting is needed. Got it, bro? Is it clear now? So this is not like if free, it is free, then we can use any subnet, any IP network. You can say subnetting allow you to use IP addresses space more efficiently rather than assigning one large network to all the devices. I can say better management. Better management. Right. With the help of subnetting, we can have isolated network. Isolated network means, let's say, let me create one network of a company. There are some switches. Each switches is connecting, let's say, 100 number of PCs. 100 PC here, 100 PC here, 100 PC here, and 100 PCs here. How many total number of PCs are there? These switches are connected with distribution layer switches. Distribution layer switch is connected with router. Router is connected with internet, ISP. Total number of IP addresses are 400. 400 client machines are there. Right. Now let's suppose there is some issue. You have to check all the switches. You have to check all the switches. You have to find the issue first, then you will fix it. Now guys, the issue is, let's say this customer is complaining that I am not able to access internet, or this customer is not able to access network resources. So you are going to troubleshoot all the devices with the help of subnetting. Just try to understand the concern. With the help of subnetting, what I can do, I can divide the large subnet, right? Let's say my earlier subnet was 10.0.0.0/16. With the help of subnetting, I am going to create one different on subnet here, which is 10.0.0.0/24. Means how many IP addresses are there? 256. For this, I'm going to use different subnet, right? That means this is different network, this is different network, this is different network. And now if this user is complaining, I'm not able to access resources or not able to access internet, I can troubleshoot it easily. I know the issue is for this subnet. And even guys, if the issue is for this entire subnet, then only this user will get impacted. Rest will be still able to access internet, right? But if you have only one subnet, which is this one, right, and there is some issue with the routing, let's say on this router, all the user will get impacted. So with the help of subnetting, what we can do, we can isolate the network, right? We can divide it into a smaller part. The another benefit of subnetting, let's suppose This is my main subnet 10.0.0.0/16, and I have some critical data here. I have some servers here, right? I want to configure quality of service. Quality of service means I want to prioritize these two servers on the router. Like I'm telling to router, bro, whenever you will receive traffic, right, always keep in mind that these two servers are critical. So please process traffic of these two servers first. I can't because router know all devices with the help of this network ID. So either router can prioritize all the users here, but again with the help of subnetting, if you will divide the network, then router knows all network by their own network ID 10.0.0.0/24. So now I can prioritize these all network. Now with the help of subnetting, I can keep these two servers in different subnet. Then I can prioritize it. I can configure quality of service for these two users. This is the benefit of subnetting. Is it clear, guys, or do you need a more example of why subnetting? No problem. Even you can, I can teach you same thing like why subnetting for 1 week. I have lots of example. Quality of service, isolation, performance, troubleshooting, security. These all are the benefit of dividing large network into a smaller network. That's why in the switching we have VLAN. With the help of VLAN also we are doing same thing. We are dividing large network into a smaller network. Clear, guys? So if someone asks you why we come up with subnetting, you can hear this answer. Now, what is subnetting? What is subnetting? So subnetting is a process of dividing large network into smaller networks. Now the most important thing is how. Yes or no? How? So guys, let's take one example of class C. First of all, by default, range of class C is range is 191 to 223, and the subnet mask is 255.255.255.0, right? Means number of network bits are 24 and number of host bits are 8. Yes or no? So as we have 8 network bits, we can create 2 to the power 8 network, and we can have 2 to the power 24 networks, and we can have 2 to the power 8 IP addresses. Now if I want to create 2 network here, what I can do, I can borrow 1 more network bits from the host bits. Right, guys, in first octet all bits are 1, 4, 5, 6, 7, 8. Right, this is first octet, first field. In first field all bits are 1. In second field also all bits are 1. In third field also all bits are 1. But in fourth field all bits are 0. Correct? What will happen if I will borrow 1 more bit here? If I will borrow 1 more network bits here, 1 dot what happened? 1.0.0.0.0.02456 What will happen now? Now subnet mask is going to be 255.255.255.128. Now tell me number of network bits. Number of network bits, guys, 25. Number of host bit, 7, right? Means valid IP addresses now. How many IPs are there? 2 to the power 7 minus 2 to the power 7, leave minus 2, means 128. Now you can see in one network we have 128 IP address. And guys, the subnetted divided network means the smaller part of network is called subnet. Network means the default network of class C, and subnet means subnetted. Subnet means network after subnetting. Subnet means a small part of network, right? So formula to calculate subnet is, means a smaller network is 2 power again n, where n is borrow bits, borrow network bits, you can say, right? So how many bits I have borrowed? 1. So guys, how many subnets are there? 2 power 1 means 2, means 2 subnets are there. First subnet is 192.168. Let's say your main subnet is 192.168.10.0. This is the main subnet. So first subnet will be same 192.168.10.0. But with the help of subnetting, I have divided into 2 parts. So what will be the network ID of second network? That is, guys,
128.
yes. For that we have one formula, that is block size, right? So we need to calculate block size here. And how to find block size? Formula is 256 minus subnet mask of last octet, means last field. What is the subnet mask of last field, guys? Or you can say subnet mask of that octet where last one is present. So last one is present in which octet? In which field? Why I am saying octet? Because we have 8 bits. 8 bits is called also octet. So last one is present over here, right, in the 4th octet. What is the subnet mask of 4th octet? 128. So 256 minus 128, what value you will get? 128. That means your next network will be 192.168.10.128, where you will add 128 block size in that octet where last one is present. Everything will happen where last one is present only, right? So my second network is guys 192.168.10.128. These are 2 networks. The first IP address of any network is represented as network ID. Network ID, as I told you yesterday, that routers are going to store network ID in their routing table. It will not store IP address. Network ID is main parents, and we cannot assign network ID to computers. This is reserved. Network ID is reserved. We cannot configure network ID to client devices. So what is the IP address? Valid IP address. First valid IP address 192.168.10.1. Second valid IP address 192.168.10.2. Last valid IP address. So guys, next network is starting from 10.128. That means this network is ending on 128. 7. Yes or no? First valid IP address of second network. Tell me the first valid IP address of second network.
129.
129. Very good. One 192.168.10.129. Second valid IP address 130. Last valid IP address 255. Even you can check what will be the next network. Next network is going to be what? Again I will add block size in 4th octet. So 128 plus 128 my block size 256. Is it a valid IP, guys? No. IP address can be 0 to 255 only. So this is not valid. That means this network is ending over here. And last IP address from the subnet is also reserved for broadcast ID. For the broadcast ID. Broadcast ID, and we can note configure broadcast ID to client machine. We cannot configure the network ID, we cannot configure the broadcast ID. So if someone will ask you about the valid host, means valid IP addresses, always subtract 2 from the total number of IP address. 1 for network ID and 1 for broadcast ID. Rest all are valid IP. So guys, tell me how many valid IP addresses are there in first network? Even you can use the formula. Formula is 2 to the power h minus 2 to the power h for total IP address, and for the valid IP address 2 power h minus 2. 2 power h minus 2. Minus 2, 1 for network ID, 1 for broadcast ID. Right? H is host bit. How many host bits are there? How many host bits are there, guys? Out of 32 bits IP address, 25 bits are network bits. Means host bits are 7. Correct? Right? And 2 to the power 7 is valid host. 2 to the power 7 is 128. 128 minus 2, 126. That means 126 valid IP addresses are there in this network. And you can see first IP address is 10.1 and last valid IP address is 10.126. Means total 126 IP addresses are there. Last valid IP address 192.168.10.6. So in both subnet we have, guys, total 126 IP addresses. Total 126 IP addresses. Right? Now let's suppose I need less than 126 IP address. I need only 50 IP address, right? I can divide it into 4 parts. Now try to understand the requirement. How I will divide network with my requirement. So guys, let's say I am designing a network where I need 50 IPs, right? So you know the formula to find the valid host. Formula to find valid host is 2 power h minus 2. Now you tell me what will be the value of h to get 50 IP address. Like I can say valid host should be greater than or equal to the power h minus 2, and valid host is 50. So 50 should be greater than and equal to the power h minus 2. Tell me what will be the value of h, guys? If h is 1, then 2 to the power
6.
1 minus 2. No.
6.
Yes. If h is 5,
Yeah, now.
if h is 5, then 2 to the
32.
power 5, 32 minus 2 means I am getting 30. So h is 6. H should be what? 6. So I have fixed it. Like h is 6. Then tell me how many network bits are there? Out of 32 bits IP, if 6 are networks, then guys, how many? 6 are host, then how many network bits are there?
2.
26 na?
2.
26. That means 26 bits are network. By default, CID subnet mask network bits for class is 24. That means I am going to borrow how many bits? 2 bits.
Oh.
Right? If I will borrow 2 bits, then subnet will be what? Number of subnet to the power 2 means 4. How many networks will be there? 4. Getting my point? Let me save this file here for you guys. I'm saying subnetting 1. I will share it after the class. Now again my main subnet is 192.168.10.0/24. Subnet mask 255.255.255.0. This is what? Classful. Default. Now tell me, I need yes. Tell me guys. Just write it in the chat. Write it in chat.
2 to 4.
Five host bit we needed.
Guys, listen my question again. I am asking you for the subnet mask, not for the network ID or network bits or host bits. I need subnet mask. What will be the subnet mask? /27. Very good. /27 means in the 4th octet 3 bits are network bits. 1 1 1. 24 is the default. 25, 26, 27, and 5 bits are 0. Right? So subnet mask will be what? 255.255.255.128 plus 64 plus 32.
2 to 4.
2 to 4. Getting my point? And if subnet mask is 2 to 4, then tell me guys block size. 256 minus 2 to 4. What will be the block size?
32.
32. Total number of subnets.
8.
2 to the power 3. 3 bits are borrowed. 8. Valid IP addresses.
$30.
Valid IP addresses 2 to the power h minus 2. H is 5. 30.
For subnet 30.
30. First subnet is going to be SIEM 192.168.10.0. Second subnet 192.168.10.32. Third subnet 192.168.10.64. Fourth subnet 192.168.10.64 plus 32, 96. Fifth subnet 192.168.10.96 plus 32. Yes.
128.
128. 192.168.10.128 plus 32, right? And so on. This is your first subnet, guys. This is the second subnet. This is third, 4, 5, 6, 7, 8, like this. Right? Now, last IP address of first subnet is going to be what? See, next subnet is starting from 32. That means this subnet will end on 31. Second subnet, last IP address.
63.
63. And so on. 95. Right? The first valid IP address. First valid IP address of second subnet. 192.168.10.32.
33.
2 na bro?
33.
Yeah, sorry. Like this. Is subnetting clear, guys, to all? How we are calculating the subnet mask and network ID? Is it clear? Now, the second question, I need 1000 IP address. For 1000 IP address, again formula is going to be same. This is my valid host, right? So valid host should be greater than or equal to the power h minus 2. Valid host should be 1000. 1000 should be greater than or equal to h minus 2. You only need to find what? The value of h. What will be the value of h here?
10.
H should be? H
10.
should be 10.
10.
Yes. H should be 10. So can I use IP from class C? No. Because in class C we have only, guys, 8 host bits. By default we have 8 host bit. We can decrease the host bit, but we cannot increase the host bit. For subnetting, what we are doing, we are decreasing the host bit. I have to use IP from class B this time. And how many bits I need to borrow?
2. 2.
2 bits. Right. I need to borrow 2 bits. So guys, let's say my subnet is, main subnet is 172.16.0.0/16, right? And after the subnetting 172.16.0.0/18. Only 2, bro. You have calculated the host bit. Host bit was 10. If host is 10, then network bit should be what? 22, na? And will be 22. By default, CIDR value for class B is 16. So you need to borrow how many bits? Hello.
6.
6 bits. You need to borrow 6 bits. First you will calculate the H value, means host bits. After that you are going to find, with the help of H, if you know the host bit, you can find the network bits, right? So in this scenario, network bit should be 22, right? And if network bits is 22/22, slash is nothing but the network bit representation, guys. With the help of subnet mask, we are representing both network bits as well as host bits, right? Like here we are able to see 24 bits are network 1 and 8 bits are 0, which is host. In CIDR, in slash notation, we are representing the network bits only, right? And here we are calculating the host bit by subtracting the network bits from the 32, which is the IPv4 address. So if CIDR value is 22, CIDR means classless interdomain routing. Classless interdomain routing. Subnetting is a classless IP addresses. Classless, you can say, routing. And the by default subnet mask is classful routing. Subnet mask will be what? If slash value is 22. If slash is 22 means how many network bits are there in third octet? 6, right? 1 1 1 1 1 1 and 2 bits are 0, right? So now you can find the subnet mask 255.255.128 plus 64 plus 32 plus 16 plus 8 plus 4. What value you will get?
252.
252 dot 0. Guys, what will be the block size? 256 minus 252. What value you will get here? 4. 4 is the block size here, right? Number of network subnets. How many bits you have borrowed? 5. So 2 to the power 5 means 32 networks are there, right? And valid host or valid IP 2 power H. H is 10.
Number of hosts.
Yeah. So host bits are 10, right? So 2 to the power 10. 1024 minus 2 means 1022. How many IP address you need? 1000, right? So this is the perfect match. First subnet is going to be 172.16.0.0. Second subnet 172.16. Where you will add the block size? In that octet where last one is present. Last one is present in third octet. Right? So 32.0. Next network 172.16.64.0 and guys so on like this. Getting my point? First subnet. First subnet 172.16.0.0. Second subnet 172.16.32.0. Third 172.16.64.0. Fourth 172.16.96.0 and so on. These are the
Increment is 64.
huh?
Increment is 64. We have 6 bits. 2 to the
No.
power 6 is 64, not 32.
Oh, sorry. Block size is 4. Extremely sorry.
Yes.
Block size is 4. So first network is going to be 172.16.0.0. Second network 172.16.4.0. Third network 172.16.8.0. Fourth network is 172.16.12.0
Well,
and so on, like this. Sorry, I thought block size is 32. Block size will tell you from where your next network is starting. Network ID will tell you the first IP address of your subnet, and broadcast ID will tell you the last IP address of your subnet. Why we have broadcast, guys? Because whenever someone want to send all traffic to all the user in that subnet, then they will send that traffic to the broadcast address, right? So first IP address of first subnet is first valid IP address 1. Second, like this, .255. Then guys, next IP 172.16.1.0. Then 1.1. .255. Then 2.0. 1.0. Like this, the last IP address will be right, and the next IP address is starting from next network. This one is the last IP address. So last valid IP address will be last valid IP address of this subnet. How many IP addresses are there in this subnet? 1022, right? In the same way, you can find the IP addresses in second subnet 4.1, 4.255, then 5.0. So this one is also valid IP address, right? This one is valid IP address. You can try it. You can try to configure it, right? Here I have GNS3. You can see. IP address 172.16.4.0. 4.0 or 5.0. Subnet mask 252.252.252.0. You can see it's working, right? That means it is a very valid IP address. Interviewer can ask you this question, right? The question is very simple. This IP address is valid or invalid? Most of the people are saying this IP address is network ID. They will ask you, can I assign this IP address to host? You will say no, because you will see 0 here. Just think about the subnet mask, right? And then decide it is a valid IP or not. So yes, this one is valid IP address. We can assign to host. Yes, fam.
Is this called subnet 0?
No, this is not subnet. This is the valid IP address, right?
4.0 network.
Yes,
This fall in 4.0 network.
yes, 4.0. Then guys,
Subnet 0 is 4.0, I think.
yeah, 4.0 is the network ID of this subnet. Subnet 0 is the different concept, right? We'll discuss it later. Subnet is a different concept. Now we are talking about the subnetting. Just focus on this. Then guys, we will have what? 5.1, 5.255, then 6.1, 6.0, 7.0, 7.1 till 7.255. If you will add 1 in this IP address, then you will get next subnet. So last valid IP address of this subnet will be 7.254. Got it? Like this you can calculate the network ID of second subnet, third subnet, and so on. Now can anyone tell me the subnet for 5000 IP address? I need 5000 IP addresses. So again, valid host should be greater than and equal to 5000. Formula 2 power h minus 2. Yes. So just match the requirement. 5000 should be greater than and equal to 2 to the power h minus 2. What will be the value of h? If you can
13,
find the
I think.
h, then you can find the n. If you know h means host bit, then you can find the n, because you know the total length of IP address is 32 bits. Simply you can subtract the h. Once you will get n, you can write down the subnet mask. Once you have subnet mask, you can choose the subnet ID, whether from class A, class B, class C. This is guys subnetting. Here you have to use IP address from which class? I can use IP from class B. But if I need 1 lakh IP address, then I have to use IP from class A. From class B you can get up to 2 power 16 IP addresses. Up to 2 power 16 IP address you can get from class B. From class C you can get up to 2 power 8 IP address, and from class A you can get 2 power up to 2 power 24 IP addresses. Now guys, VLSM. See, in this scenario the length of each network is equal. Length of each network is equal. And guys, if subnetting is new for you, if you are learning subnetting for the first time, then lots of effort is required. You need to solve lots of questions, you have to watch videos, you have to open book, right? And hardly just you have to spend 2 to 3 days on subnetting only. Then you will get the fundamental knowledge. Once you will get the fundamental knowledge, you will never forget it. In your entire life you will be solving the subnetting, and as I told you, in real time, every days you will be using subnetting while troubleshooting the network, while designing the network, implementing the network. Everywhere we will be using subnetting only. For the IP addressing, subnetting, right? Now the VLSM. Here issue is length of each network is equal. So if someone will tell you to design a network, choose a subnet ID for their requirement. Like their requirement is, I need 100 valid IPs, you can perform the subnetting, right? Or they can tell you I need 8 subnets. Then also you can find the subnet mask, because you know the formula to calculate subnet is 2 to the power n, right? So 2 to the power n should be greater than or equal to 8. What will be the value of n, guys? N should be 3. N is what? Borrow bit. So we need to borrow how many bits? 3 bits. We need to borrow 3 bits. So my slash value can be 27, right? So you can find the subnet mask for number of valid IP address. You can find the subnet mask for number of subnets, right? Or someone can tell you just to divide one network 192.168.10.0/24 into 8 part, into 5 part, into 3 part, like that. So we cannot divide network into 3 part. Either we can divide network into 2 part, 4 part, 8 part, 16 part, 32 part, 64 parts, like this. Now I have two router, R1, R2. Guys, between router 1 and router 2, how many IP addresses are required? I need one subnet here between router 1 and router 2. And how many IP addresses are required? 2. 1
4.
for one IP address, bro. 1 for router 1 and 1 for router 2. The valid IP addresses are 2. So what should be the subnet mask? So valid host 2 to the power h minus 2 should be greater than or equal to 2. Formula of valid host is 2 to the power h minus 2 should be greater than or equal to 2. What should be the value of h?
6, 252.
H should be what? H.
Host bit.
If
Oh.
h is 1, then you know the requirement is not matching. If h is 2, then requirement is matching. 4 minus 2, 2. Correct? So if there are only 2 host bits, that means network bits are 30, right? So between routers we will be always using /30. Even you can see in my GNS3 I am using what? /30. Reason, guys, I need only 2 IP addresses here. Right? And for /30, subnet mask will be 255.255.255.252. Block size will be 256 minus 252 means 4. Right? So let's say my main network ID is 192.168.10.0/24. So first network 192.168.10.0. Second network 192.168.10.4. Third network 192.168.10.8. Fourth network 192.168.10.12. Last IP address of first network will be 10.3, right? This is what? Broadcast ID. This is what? Network ID. First valid IP address is 10.1. Last valid IP address is 10.2. So how many valid IP addresses are there? Only 2. I can configure this on router 1. I can configure this on router 2. In second network, again, last IP address 10.7. Right? First valid IP address 10.5. Last valid IP address 10.6. Here 10.9, 10.10. Last IP 10.11. 10.13, 10.14, 10.15, and 10.16 will be next network. So if I have router 1, router 2, router 3, router 4, here I can use which subnet? This subnet. Here I can use this subnet. Here I can use this subnet, right? My main network is this one. I have divided it into multiple parts. Into how many part I have divided, guys? Can anyone tell me the total number of subnets? See now, n is 30. Means how many bits I have borrowed?
2
6.
bits.
2 bits. How
No,
many
no, no,
more
sorry.
bits I
6
have borrowed?
bits. 6. 6.
6 bits, na? Because by default CIDR value for class C is 24. I am using 30. That means I have borrowed 6 bits. Means how many networks are there? 2 to the power 6 subnets. Total number of subnets. 2 to the power 6 is 64. That means 64 subnets are there. I can use these subnets between 64 routers. Right? So I have divided this network into 64 parts. And the size of all network is, guys, equal. Right? So this is what FLSM, fixed length subnet masking, means length of each subnet is fixed, same. What if length is different? If length of each network is same, then you can do FLSM. If length is not same, then you will use VLSM, variable length subnet masking, but the concept is exactly same. Now let's say in my company I need to do subnetting for multiple networks. Network 1, where I need 100 IP addresses. Network 2, I need 50 IP addresses. Network 3, where we have, let's say, servers, I need only 20 IP addresses. So in this scenario, length of my network is not same. Length is variable. Then how to perform subnetting? So guys, if length is variable, then we are going to perform VLSM. And for the VLSM, first of all, you have to arrange your requirement in the descending order, right? Where you need the maximum IP address, you will put that on top, right? So the maximum IP address is in network 1. So I have put it in top, then 50, then 20. Now we'll perform subnetting for this network first. Then for this network, same FLSM. Then for this network, FLSM. How? Let me show you. The main subnet is 192.168.10.0/24. Now I need valid IP address. Valid IP equals 100. That means guys, 100 should be greater than and equal to, what should be the H? What will be H?
7.
7. And will be what then?
1.
25, right? Total network bits. Borrowed network bits is 1. I have borrowed 1 network bits, right? So guys, CIDR value is very clear. That is 25. Means subnet mask 255.255.255.0. And how many subnets are there? 2 subnets are there. First subnet is 192.168.10.0/25. Second subnet 10.128/25. Fine. Here how many valid IP addresses are there? 126. This is perfect for network 1. In this network again I have what? 126 IP address, but I need 50 only. So I will perform subnetting now on this network, right? So here I will use formula 2 to the power h minus 2 should be greater than and equal to 50. 50 should be greater than or equal to 2 to the power h minus 2 should be greater than or equal to 50. What should be the value of h here, guys?
6.
H should be 6. So N will be what?
27.
47.
26. No, 26.
26, right? That means I have borrowed 2 bits. So how many network bits are there? Sorry, how many subnets are there? 4,
4.
right? Now I have 4 subnets. First subnet is this one, and second subnet is 192.168.10. I will add block size. How to find block size? 255.255.255.224. So 256 minus subnet mask. What value I will get here? 32, right? So next network is going to be, guys, 128 plus 32. What value you will get here? 0, 8 plus 2, 0, 5, 6, 160, correct? How many valid hosts are there? 62. This is perfect match for second network. And now I will perform subnetting on this network for third network. So here I need what? 2 to the power h minus 2 should be greater than or equal to 20. Again, you can find h value, you can find h and the network ID. So what I will do, I will use this subnet for network A. For network 1, my subnet is 192.168.10.0/25. For network 2, 192.168.10.128/26. For third network, 192.168.10.160 slash, what should be the h, guys, here? For 20, 5. H should be
5.
5. Then n will be what?
3.
27. So here I will use 27. Now you can see the number of valid IP address in each subnet is variable, not same, right? In this network we have how many IPs? 126. Here how many IPs? 62. Here how many IPs? How many IPs are there? 30. Right? So we have 10 extra IP in network 3, third network. I have 12 extra IP in network 2, and I have 26 extra IP in network 1. This is nothing but the VLSM. The length of each subnet is variable. So I have covered subnetting, FLSM as well as VLSM. Now if anyone have question, guys, please ask. Otherwise from tomorrow we are going to start the actual networking. By the way, this is more important than actual networking, like the routing or any other topics, because everything is based on subnetting only. So if you are not clear with subnetting, watch this video again before next class and try to solve the question by yourself, right? What I am going to do, I am going to share one PDF for the subnetting questions. If you are able to solve these all questions, then only leave subnetting. Until and unless you are not able to solve these all questions, guys, keep working yourself on subnetting. And these questions are, I have collected these questions from CCNA 200301 version 1.1 exam code. This is important for your CCNA exam, right? So see, the question is, enter the last valid IP. Host means the IP. Last valid host on the network that the host 10.86.86.64/27 is a part of. This is a valid IP address right? So first you have to find the network ID of this valid IP address, and then you have to find the last valid IP address of that subnet. So can anyone tell me the answer?
Sorry, sir. IP address
Sir, I
is
cannot see your screen.
10 dot.
Cisco is not going to ask you question directly, right? They will ask you question in this way. No answer till here? 224?
Can't see your screen, boss.
You're, you're, you're not sharing the screen, sir, actually.
And I stop sharing. I've shared again. Is it visible now?
Yes. Yes.
See the question. Enter the last valid host IP address on the network that the host, this one, 10.86.86.62/27 is a part of. Means this is a valid IP address. First you have to find the network ID of this IP address and then last IP address of that network. Right? So guys, how to find the network ID of this IP address? Slash value is 27 means subnet mask will be what? I have borrowed 3 bits. 224. Correct? That means block size is 256 minus 224. What will be the block size? 32.
32.
Right? So first network will be 10.86.86.0. Second network will be 10.86.86.32. Third network will be 10.86.86.60.
60.
64.
Then 10.86.86.64 plus 32.
96.
96. Now you tell me this IP address is a part of which network? This is the first network, second network, third network and fourth network. This IP address is a part of which network?
Second.
Second network, right? So tell me the last IP address of second network.
63.
86.63, right? And last valid IP address will be, this is the broadcast ID,
62.
86.62. So which one is the right answer? Option D. Right. So guys, please check these all question. If you are able to solve these all question by yourself, that means your subnetting is clear. Then you can move. Until and unless you are not able to solve these all questions, that means you are still lacking in subnetting. So I am sharing this PDF with you and try to solve the questions. All are based on CCNA 200301 exam. By the way, you have already this PDF. Okay, I will be sharing. Okay, any other question?